got 4 students here, and these are their ages. Draw dots at 19, a dot at 23, a dot at 25, and a dot at 20. Okay. What is the mean here? Yeah. So my mean. X bar again is the symbol for mean. So you get used to seeing the mean written that way rather than me writing out. Okay. So 21.75, I'm going to draw a line right here. This represents the mean. So this is one idea or one way to interpret the standard deviation, okay? What is the difference between this point, the 19, and the mean? How far is it from the mean? If I draw a line at 19, I can figure this out. This point is 2.75 from the mean, right? It's 2.75 below. What about this one? Yeah, 1.75 from the mean, negative 1.75 below. How far is this one from the mean? This is 1.25 above the mean. And this one is 3.25 above the mean. So we're not going to just take, if I add all of those up, I'm going to get 0. Okay? What we're going to do for the standard deviation is I'm going to square this difference and take kind of the average of those squares. Okay? So I'm going to say this point 19, I've got 4 points, and that means, and I figure out how far each one is from the mean. Is everyone following me? No. You guys are not following me. Okay, good. I'm glad I asked that question because I have a feeling some of you guys are just going to draw 4 dots and lines in this thing and say, what is going on? Okay? This is no good. All right. Okay, so here I've got 4 dots, right, on my dot plot. And we're good there. Okay? And then I found the mean. Are we okay with finding the mean? And what was my mean? 21.75. So I drew a line at the mean, and this is the mean. And then I asked, how far away is this point from the mean? Okay, so I said, this point is located at 23. So what do? I do 23 minus the mean. So I did 23 minus 21.75. And I got 1.25. So this point is 1.25 from there. You know what? Let me just change our numbers a little bit, okay? And I think this will make our concept a lot easier. Okay, so sorry, you might just have to redraw something here, but I'm going to put 26 there instead. Okay, sorry about that. We'll do this. We'll all like it. Okay. I promise. You'll like it, all right? Come on. I've got 4 points, 19, 23, 20, and 26, okay? dot plot. 19, 23, 26, and 20. What is my mean? X bar is 22. Okay, I think this will make everybody's life easier. My mean is 22, okay? So on your piece of paper, draw a line at the mean. I got 4 data points. These are my 4 dots. Tell me, how far is each one away from the mean? Okay, how far is this dot away from the mean? It's 3 units below the mean. It's -3 from the mean. Can we see that?
Yes.
Is everyone good? Okay, so this dot is 3 units below the mean. Is that okay? How far is this one from the mean? 4. It's 4. This one is 4 above the mean. Yeah, you just add and subtract. So how far is this one from the mean?
1.
It's 1. And how far is this one from the mean? -2. It's 2 below the mean. Now, is everyone okay?
Yes.
Yes. Is anyone not okay? Don't be shy, please. Okay? Because nobody's saying anything, I'm going to assume we're okay, and we're going to keep going here. So what we're going to do, yes?
So for each point that's on there represents the 4 students, and you just
And I'm just saying.
subtract one of the numbers or add to the mean, which gets us those
Yeah,
4.
we're I'll go through the process here, but basically I subtracted the mean. I said the mean is equal to 22, and then I said basically I did 19 minus 22 gave me -3, and then I did 20 minus 22 gave me -2. I did 23 minus 22 gave me 1, and 26 minus 22 gave me 4. Okay? And what I'm going to do is I'm going to say, I'm going to take this difference and I'm going to square them, okay? Don't ask me why. This is what we've decided. There is an answer, okay? And we're trying to minimize the square distance from the mean, but that's okay. We're going to square it, and we're going to take almost the average of the squared distances, okay? So if I square -3, what do I get?
9.
9. Positive 9, right?
Yes.
Okay, so these numbers, this -3, -2, 1, and 4, these represent what? The distance from the mean. Okay? So this is how far each student is from average. Okay? So the average age here, the mean age is 22. How different is a student from average? This student was 3 years below, or three away. And I'm going to square that. Okay, so I square the distances. Square the distance from the mean. And what are the numbers that I get?
9, 4.
Okay, I'm going to get 9. -2 squared gives me 4. And then what else do I have? 1 squared gives me 1, and 4 squared gives me 16. Very good. Okay. If I add all of these up, what do I get? 30. Okay. Now this is the weird part. If I wanted to take the average, I would add all of these up. I'd get 30, and then I would divide by 4, right? Now, the weird thing is when we do standard deviation, we don't divide by 4, we divide by 1 less than what we were going to do, okay? So we do 30, and we divide by 3, okay? So we divide by n minus 1. And don't worry, I'll write a summary for all of this stuff, okay? And then I get 10. Okay, so this is kind of my... so this number 10, this is my variation, and it's the kind of average of these squared distances from the mean. Okay? So this is the distance from the mean, right? These numbers was the distance from the mean. I squared them and I got these numbers, and then I'm taking the kind of average and I'm getting 10. Okay? This is the variation. I know. It's like, what are you doing? Okay? Okay. I know it feels that way. Alright? Anytime somebody just does a bunch of stuff on the board, it feels that way. Okay? But it'll make sense, okay? Well, I hope. Again, what does the standard deviation tell us? Don't get lost. Don't lose the big picture. The spread. Okay, that's all you need to know. All right? I mean, well, not all you need to know, but that's the most important thing. All right? It tells us the spread. And if we have a data set where the standard deviation is 4, and we look at another data set and the standard deviation is 10, what does that tell us about the group with standard deviation 4?
A little variation.
It had less variation, it had less spread, the numbers were more similar to each other, and this data set where the standard deviation was 10 had more difference, the numbers were more different from each other. Okay? That's the key part. Yes, there's this weird thing that we got to go through to find it, but we have a question.
Sorry, I'm confused.
That's okay.
I'm sorry if I'm getting it wrong, but do we have to get the square root of 10?
Yeah, we're going to take the square root of this, okay? So the standard deviation is I take the square root of 10 and I get, what, 3.14 or something? I don't know. .16, okay? And this is my standard deviation. Okay? So 10 was the variation. This is the statistical variation. And then the square root of this variation is 3.16. This is my standard deviation. That's the standard deviation. Square root of the statistical variation. Huh? It feels like a lot. It's not too bad. Yes?
So n minus 4.
Why do we divide by 3? That's just, I'm just going to say that's what we do, okay? It's like taking the average, but it's not, okay? All right, here we'll, let me write the summary, and then I'll give you another exercise where you find the standard deviation. All right, hang in there, you guys. Okay, so to find the standard deviation, all right, the very first step is find the mean. Second step, find the deviations from the mean, okay?
That's like when you did the plus 3 minus 2.
Yeah. Okay, so find the deviations from the mean. Basically, just subtract the mean from every single number. Okay, this is not, none of these steps are hard. It's just
The order.
following them, okay? Find the mean, then you subtract the mean from each number, which tells you the deviations. Square the deviations. Okay? Add up the deviations, or add up the squares. Divide by n minus 1, and then take the square root. And this gives you the standard deviation. And what does the standard deviation tell you? The spread. The spread, okay? Don't lose sight of the big picture. Okay, so these are the 6 steps you need to do. Some of you guys like formulas, so I'll put up the formula on the board. Yes, we have a question.
So for number 5 where it says divide n by 1.
Divide by n minus 1.
Yeah, n is the variation.
No. Divide by n minus 1.
And then, and then you get the variation.
And then you get the variation.
Okay.
And then you take the square root.
Yeah.
So divide by the quantity n minus 1, okay? What is n? Number of numbers, okay? The number of numbers. N is the number of numbers, or the size of your sample. Okay? Standard deviation, the symbol that we use for standard deviation is S. And the formula for it okay? Of course, no. No. Alright? Well, you gotta know one or the other, right? So, yeah, you gotta know how to find the standard deviation. And this is the formula that you use, okay? But it looks scary, all right? Formulas like this, when there's more than one letter involved, suddenly seem scary. But it's not, okay? All of the steps for finding the standard deviation are found in this formula, okay? What is the very first step? Find the mean, right? And we see that right here by seeing x bar. X bar is the symbol for mean, so this is step 1. Okay, what's the second step? Find the deviations or subtract the mean from each number. And we see that here with this minus sign, x minus the mean. So that means for each x, for every single number, we subtract off the mean. That's step 2. What's the third step? Square those deviations. And we see that by this number right here. The squaring is that. And then add up the squares. Where do we see that? No? Step 4, add up the squares. That's this thing, okay? Sigma means add up. And once we do that, what's our next step? Divide by n minus 1. Right there, that's step 5. And then the last thing we do is we take the square root. Okay? Alright, so let's try to, I'm going to put some numbers up here. So let's say let's say you have 4 kids in this one group, okay? And their ages are 4, 6, 6, and okay. Find the standard deviation of the ages. Just got to follow these steps right here. You have the answer? Okay, great. 6 is bigger than 6. So don't worry about this picture. Just try to follow those steps, okay? Find the mean, find the deviation. There you go. Okay, so just be careful. What happens when you square a negative number? Yeah, no. A negative times a negative gives you a positive. Yes, I think. I know. Don't. That's because your calculator is doing this order of operations thing where it's applying the negative at the end. You just know that they're all positive. Did you get that? Yeah. Huh? Sort of? 2.5.
And then we subtract 6.5 for each one. First, 4 minus 6.5.
Okay.
That's the answer?
That is the answer. All right, I put the answer up on the board, but let's try this, okay? Some of you guys are drawing, pictures for yourself, which is fine, but you don't have to draw those pictures, okay? What is the very first step that we're supposed to do? Find the mean. What is our mean? 6.5, okay? Anybody having trouble getting the mean to be 6.5? Okay, good. I'm going to then do what is step 2? Subtract the mean from each number, okay? So I've rewritten the 4 numbers, 4, 6, 6, and 10, and I'm going to subtract off the mean from each number, okay? So the mean is 6.5, I'm going to subtract off 6.5 from each number. Here, this gives me negative 2.5, this gives me negative 0.5, this gives me negative 0.5, and this gives me 3.5. This is step 2, right? Yes?
Since the mean is in the middle, shouldn't one of the 6's, shouldn't one of those be a positive number?
No. Why would that? No. Okay. Just subtract the mean from each number. Okay. The mean is not in the middle. The mean is the balancing point. Okay. I think you're getting the mean mixed up with the median. Okay. So now, if we were to make a bar dot plot, okay, it'll look like this: 4, 6, 6, and 10. Okay, and my mean is right here. Okay, we don't have to worry about that. Okay, this is step 2. What is step 3? Square each of these things. Okay, so I do 2.5, negative 2.5 squared. What does that give me? 6.25. Okay, now be careful. Sometimes if you punch negative 2.5 in your calculator and you square it, it's going to give you back a negative number. That's not the case. Anytime you square a number, you get a positive number. Okay? If you did negative 2.5 in parentheses squared, it will give you the positive number. But the calculator observes order of operations, so it sees the negative at the end. It does exponentiation first and then multiplication, right? PEMDAS, exponents, then multiplication. Basically, a negative means multiply by negative 1. That's what's happening. So 0.5 squared gives me 0.25, 0.5 squared gives me 0.25, and 3.5 gives me 12.25. So far, so good?
Yeah.
Okay, the fourth step is add up all of those squares. So I do 6.25 plus 0.25 plus 0.25 plus 12.25, and I get 19. I divide by n minus 1. What is my n?
4.
So I do 19 divided by n minus 1. So 4 minus 1 is 3. So 19 divided by 3 gives me 6.33. And the last step, I take the square root of 6.33, and I get 2.5166. That is our answer. Yes?
What decimal do you usually want us to,
Round off, I don't know, keep 3 or 4 decimal places, I would say. Okay? Yes?
So what happens when you have a large sample for like 30? It's
Uh-huh.
a lot more work.
Yeah, with 30 numbers, it's a lot more work. You're right. Okay? Because you got it. Well, first off, you got to add up all 30 numbers and divide by 30 to get your mean, right? And then you got to take that number and you subtract it off from all 30 numbers, and then you square that difference for all 30 numbers, and then you add them all up, and then you divide by 29, right? And you take the square root. So yeah, with 30 numbers, it's a lot of work. Okay? Usually, we have computers to do our grunt work now. So if we had 30 numbers, we just put them into the computer, and we say, computer, find the standard deviation for me, and it will do that for you, okay? But in terms of finding the standard deviation by hand, yeah, for 30 numbers, it's a lot of work. I think it's reasonable to ask you guys to find the standard deviation for a set of maybe 5 or 6 numbers, okay? Beyond that, I would agree, it starts to get tedious. Yes?
Is it okay if our decimals are off by like a couple numbers, like at the end? Like, I didn't get .5166, I got like 5159.
5159. Okay. Yeah, that probably happened because you rounded off this too early. So if you leave it at 6.333 or something, yeah, that's fine. Okay. If you're off by a tiny bit,
Is that okay?
it's okay. It's okay. All right. So know this process for finding the standard deviation. Okay. With that, why don't we take a little break? We'll come back in about 10 minutes and we'll finish up our class.